Scientists have installed 3 new temporary seismic stations to monitor a spike in earthquakes on Mount Adams.
A slumbering giant has awakened, and the ground beneath Mount Adams is revealing a story that scientists can't ignore. A remarkable 800% increase in seismic activity has disrupted the volcano's usual stillness, sending ripples of concern throughout the Pacific Northwest. Could this be the beginning of an event unseen for thousands of years? From deep, unexplained tremors beneath the surface to striking evidence of magma in motion, the signs are as fascinating as they are alarming. This towering stratovolcano, once considered dormant, may be hiding secrets that could reshape the region forever. What's causing this seismic anomaly? Is it just a temporary geological fluctuation, or could it signal something far more significant? Stay with us as we explore the clues and uncover just how close we might be to an extraordinary natural event. Mount Adams has captured the attention of scientists and residents alike with a staggering 800% increase in seismic activity, as reported by the Cascadia Monitoring System and the U.S. Geological Survey (USGS). Typically, this dormant stratovolcano experiences only one earthquake every 1 to 2 years, but in a single month, 6 earthquakes were recorded, an occurrence far beyond its usual patterns. Ranging from magnitudes of 0.9 to 2.0, these tremors were shallow, occurring between 3,000 feet above and just below sea level. This deviation from the norm suggests a significant shift in the volcano's behavior. One of the most concerning events was a magnitude 2.0 earthquake recorded at 1 kilometer above sea level, indicating ground elevation changes caused by subsurface forces. The shallow depths of the earthquakes suggest magma movement beneath the surface, a clear sign of increased volcanic activity. While not definitive evidence of an impending eruption, these anomalies align with patterns observed in other volcanoes before they became active. The sudden clustering of tremors only highlights the challenges in monitoring an active site like Mount Adams. The area is primarily served by a single seismic station, ASR-2, located 7 miles southwest of the summit, with no redundancy or support from additional monitoring systems. Although the unusual activity has been detected by this station, the exact locations of the earthquakes and the full extent of the unrest remain unclear. This gap in data calls for the urgent installation of more monitoring systems to keep track of these developments. Despite the seismic drama, Mount Adams is still classified at a very low alert level, green, by the USGS. However, this surge in activity continues to draw attention, as such increases in seismic events can often precede more dramatic volcanic behavior. Whether this is a temporary fluctuation or the start of a long-term shift in the volcano's dormancy, the recent earthquakes serve as a stark reminder of the unpredictability of Earth's subsurface dynamics. While Mount Adams' increased seismic activity is alarming, the immediate threat to nearby communities isn't an eruption, it's lahars. These destructive mudflows, composed of ash, rock, and melted ice, can travel at incredible speeds, devastating everything in their path. Historical records show that Mount Adams has produced massive lahars, some of which reshaped the landscape miles away from the volcano. Unlike eruptions, lahars can occur even during dormant periods, triggered by seismic activity, glacier collapse, or hydrothermal events. One of the most catastrophic lahars in Mount Adams history was the Trout Lake Lahar, which occurred around 6,000 years ago. Originating from the volcano's southwest flank, this event carried enormous amounts of debris downstream, covering 15 kilometers of lowlands. The sheer volume of debris formed Trout Lake and left deposits as thick as 65 feet, with debris traveling as far as 37 miles from its source. Such events, like the more recent lahar that occurred about 300 years ago, demonstrate that the threat of lahars remains very real. These flows, triggered by weakened rocks and hydrothermal activity, remind us of the mountain's volatile nature. Constant avalanches and debris flows near Avalanche Glacier further highlight the instability of the volcanic terrain. Lahars are particularly dangerous because, unlike eruptions, they can strike without warning, catching communities living downstream off guard, especially those in low-lying areas around rivers and lakes. Emergency preparedness plans are essential to mitigate the damage to life and property. With the increasing seismic activity beneath Mount Adams, Understanding how lahars are triggered and how they behave is critical to protecting those living in the volcano's shadow. Mount Adams is not an isolated volcano. It is part of the Cascadian volcanic arc, a geologically dynamic region stretching across the Pacific Northwest. Recent research suggests that volcanoes in this area, Mount Adams, Mount St. Helens, and Mount Rainier, may share interconnected magma systems. This vast underground network of molten rock links the activity of these volcanoes, with movement in one potentially influencing the others. Studies show that Mount Adams sits atop a massive magma reservoir, large enough to fill Lake Michigan 2.6 times. This reservoir is part of a broader system that may also feed Mount St. Helens and Mount Rainier, connecting these volcanoes through deep subterranean pathways. The convergence of the Juan de Fuca plate and the North American plate generates the heat and pressure necessary to produce magma, feeding volcanic activity in the region, including the seismic surge at Mount Adams. Understanding this interconnected system is crucial for forecasting potential changes and effects on neighboring volcanoes. Mount Adams, as part of this network, highlights the need for more coordinated monitoring of the Cascadian volcanoes, as the volcanic activity in one may have significant implications for others. While Mount Adams is often overshadowed by its more famous neighbors like Mount St. Helens and Mount Rainier, it holds a unique place in the Cascade Range. As the second largest volcano in the Cascades by volume, its towering presence and sprawling glaciers dominate the landscape. Despite its long dormancy, the recent surge in seismic activity has brought Mount Adams back into focus, reminding scientists and residents of its potential volatility. What sets Mount Adams apart is its history of producing large, destructive debris avalanches and lahars, even during dormant periods. A massive landslide 6,000 years ago reshaped the southwest flank of the volcano, creating the Trout Lake Lahar and depositing debris up to 65 feet thick miles downstream. Smaller avalanches and debris flows have occurred more recently, particularly near Avalanche Glacier, which has seen several events since 1921. These incidents highlight the volcano's unstable terrain, a result of its heavily glaciated slopes and ongoing geological processes. Mount Adams sits directly above the regional magma system, further emphasizing its potential for sudden, significant events. While other Cascade volcanoes may be more active, the magma beneath Mount Adams remains a powerful and unpredictable force, requiring close monitoring and preparedness. Similar to liquid concrete, potentially devastating low-lying communities. Emergency preparedness and evacuation plans are essential for mitigating these risks, as past lahars have caused significant damage to the surrounding areas. Local authorities and scientists are working to improve early warning systems, but challenges remain due to the sparse monitoring infrastructure. The implementation of comprehensive evacuation plans and public education campaigns will be crucial in minimizing future damage. Collaboration with indigenous groups, such as the Yakama Nation, who have a deep cultural connection to the region, could provide valuable insights into historical volcanic activity and help strengthen disaster preparedness efforts. In summary, while Mount Adams currently maintains a green, alert level, the increased seismic activity serves as a reminder of the potential dangers the volcano poses. Enhanced monitoring and community preparedness are critical to understanding and mitigating the risks associated with this unpredictable and active landscape. Integrating traditional ecological knowledge and stories into educational campaigns can have a profound impact on local populations, ensuring that preparedness messages reach a broader audience. By blending modern scientific methods with traditional wisdom, we can create a more inclusive and well-rounded approach to managing the risks associated with Mount Adams. The recent increase in seismic activity at Mount Adams highlights the urgent need for enhanced monitoring systems and preparedness plans. The current seismic network, with just one primary station near the volcano, is insufficient to provide a complete picture of its activity. To fill this gap, the Cascades Volcano Observatory is deploying additional temporary stations, but a permanent and robust monitoring system is crucial for long-term safety. One key area for improvement is gas emission monitoring. Unlike other Cascade volcanoes, Mount Adams lacks the equipment to measure volcanic gases such as sulfur dioxide and carbon dioxide, which are important indicators of magma movement and pressure changes. Integrating gas sensors into the monitoring network would provide a more comprehensive understanding of the volcano's activity and offer earlier warnings. Public education and emergency preparedness are equally important. Clear evacuation routes, hazard awareness campaigns, and real-time communication systems are critical for the safety of communities living near Mount Adams. Past events like the Trout Lake Lahar demonstrate the potential catastrophic impact of such hazards, even in the absence of an eruption. New technologies, like portable seismic stations, drones with thermal imaging, and satellite-based ground deformation tracking, offer real-time insights into the volcano's behavior. These innovations are vital for improving early warning capabilities and refining hazard models. Mount Adams remains a potent reminder of nature's unpredictability and the need to stay ahead of potential volcanic hazards. With continued advancements in monitoring technology, preparedness, and community engagement, we can better adapt to the challenges posed by this unpredictable force of nature. The future depends on our ability to anticipate and respond to the dynamic forces beneath our feet.